Okay, hello folks. It's now 1 o'clock in the afternoon in Bangkok, 8 a.m. where I am. So I guess we can start. Um, okay. So it's Thursday now, so I think by now you've seen this slide several times this week, and you know what it says. It's all kind of stuff about IPR, code of conduct, copyright, patents, even privacy policy. Note really well that everything here is defined in the guideline there for conduct, anti-harassment policy. If you feel that you are harassed, you can, of course, talk to the chairs of a particular session or to the ombuds team who are supposed to police us all. Next. Hearing tips, if you are remote like me, please use headset like me. Participate in the show of hands. If you are local, still every comment has to go to the mic so that it is both heard by remote participants and that it is recorded in YouTube so we can hear your comment forever. And if you're not talking, make your mic silent. All right, and we generally don't have everybody's video on. Okay. Right. So here are links to the agenda, MeetEcho information, and technical assistance. So we have administrivia and agenda bashing. We'll talk about the document status. Then we'll have presentations, a short one from Aaron about ACME RIN profiles, VPN node ID, and DNS update, and RATs, JOT claim constraints, and PK challenges. Right, and so we have a pretty full agenda today. Any bashing? Sorry. Okay, so still no new RFCs since September of 2023.
Mike has something.
Okay.
I have an agenda bash.
Oh.
If there's time at the end in any other business, I'd like to comment on the status of the auto discovery drafts. I have things to say.
That would be great. Also, thanks to Mike for volunteering to be the scribe. Okay, so as I said, no new RFCs since September of 2023. However, this might change by the next IETF meeting because ACME ARI, since the last meeting, got revision 7 and 8. It went through IETF last call, finished on December 6th, approved by the ISG February 27th, and it's now in the RFC editor's queue. Also, ACME integrations for device certificate enrollment has been in the RFC editor's queue since July of 2023 because of misrefs, both for Anima Brusky Cloud and LAMP's RFC 7030 CSR attributes. Both of those we were waiting for a long time, but both have gone through IETF last call since the last meeting, so progress. They're still not approved by the ISG, but hopefully that comes soon. ACME Onion, also since last meeting, we've had revisions 5, 6, and 7. IETF last call ended November 26th, approved by the ISG January 15th, and it's also in the RFC editor's queue. So we could have 3 new RFCs by next IETF. And there's ACME DTN Node ID, which went through last call in 2021. And we were waiting for DTN work, and they're not going to give you spoilers because there's a presentation in a few minutes. ACME client, there's been, after having been dead for a while, there's 2 new revisions since last meeting, and no real engagement on the mailing list, so I'm not sure where that is going. And there's the ACME DNS account label, that's a new draft. We only have 1 revision, that's 00, and there's a presentation. Okay. Any comments before we go directly to presentations? All right. So, Aaron.
There we go. Howdy, folks. Pretty quick one from me today.
Just a minute. Sorry, I mistakenly said that Mike volunteered to be scribed. It's Aaron that volunteered to be scribed. So, thank you kindly. Okay, I'll mute myself now.
Pretty quick update from me. First, I'll be talking about ACME renewal information, ARI or ARI, as I tend to call it. Next slide. Since IETF 121, 2 new versions have been published, Draft 7 and Draft 8. Both of these were published as a result of feedback received from the wider IETF community. So Draft 6 was sent to the IESG for consideration as a proposed standard, got a bunch of feedback from a variety of folks from GenArt and DNSDear and all those amazing groups. Rewrote a big portion of the client scheduling requirements and recommendations, added a new paragraph to the security considerations, made a bunch of small editorial improvements, and as a result of that, it got sent to IESG for ballot. Got a little bit more feedback at that level, some further improvements to client scheduling, changed some shoulds to musts to make things a little stricter, more editorial improvements, and it passed that ballot, approved as a proposed standard, and it is, as Yov was saying just a moment ago, it is now in the RFC editor's queue. Next slide. So, as I said, like, not a lot to say. On the one hand, it's a big update. On the other hand, the document itself has changed barely at all. So I just want to give thanks to all the people who have provided feedback in these last 2 document cycles, all the people reviewing it from the IESG level. Thank you to all of these folks for all of their fantastic feedback and reviews. And that's all I have to say about renewal info. Any questions about that before we move on to profiles? Cool. Let's talk profiles. This is going to be a similarly quick update. The profiles document has not been updated since IETF 121. It has received very little mailing list conversation and very little activity on the GitHub repo. People aren't expressing strong opinions about it. But since IETF 121, the implementation of the ACME profiles extension has been deployed by Let's Encrypt in both the staging, like pre-production and full production environments. Each of those environments has multiple profiles configured and clients actively requesting those profiles. And in order for that to be happening, it has been implemented on the client side by at least these 6 ACME clients. They're all on the slides. I don't need to read them all. But clients seem to be implementing it. It has been fairly easy for most of them to implement. The integrations with the Let's Encrypt servers have been going well. And none of the client authors who have implemented the client side have shown up with comments or questions on the ACME mailing list or on the GitHub repo. So despite all of this implementation effort, no changes to the document, which is pretty good as far as I'm concerned. Next slide. So yeah, open call for comments, questions, feedback, and open call for like, is this a thing that the rest of the working group thinks is actually a problem worth tackling at the standardization level? Is this a thing that people think we should do a call for adoption for? All that sort of goodness. Yeah, that's it for me. David Benjamin.
David Benjamin. Yeah, it seems we should do a call for adoption if it's already gotten as far as deploying it and seems useful. Yeah, one realization I had at some point with this is that like the reason you would want to do something like profiles over just saying like use a different URL for the different kinds is that way you get to share the account information. So I think that was sort of the like main convincing factor for me that like this design makes sense.
Yeah, thank you.
Okay, anyone else? Okay, I don't think we're starting adoption call based on that one comment, but take it to the list.
That's what I was expecting.
Yeah. Okay, thank you. ACME DTN node ID, Brian.
Hello, the status is going to be pretty short and a simple request coming out of it. So if you could go to the next slide, please. So the last draft is revision 16. That dependency that Yov had mentioned is now actually published as RC 9713. So the validation method name was updated to make it a little more protocol specific and a little more experimental looking, and the dependency was updated. So at this point, this document is ready. It needs reconfirmation. It needs to, I don't know the exact specific process, but effectively a last call, I think.
Yeah, it's pretty much an ad hoc process. We'll do it, I guess, next week and make it 2 weeks so it's like a working group last call.
Sure. And I'll just mention it's part of the document, but the method presented here is basically the same as the SMIME RFC 8823, but with a different transport and without all of the MIME messiness.
Mm-hmm. Okay.
Thank you.
Any comments? Oh, Deb.
Sorry, I'm short. So just to clarify, you're going to issue a short working group last call, like a couple of weeks?
Yeah.
Okay. Do you, have we requested early reviews for this before or no?
Oh, it's gone through everything.
It's already gone through the ISG, right? But
yeah.
do you?
Yeah.
Oh, all right. All right.
It was setting in that waiting pattern.
No, I know. I know. I was the one that set. So just do a short working group last call and let's get it moving, right? Otherwise, it's not going to be experimental anymore.
Yeah, basically. Thank you.
Okay, thank you. And next we have DNS update. That's Lee.
Yeah, hello, can you hear me?
Yes, very well.
Oh, great. Good afternoon to everybody. I'm Ruochen from Huawei, and this is actually my first time participating in IETF meeting, so very excited to be here.
Okay,
Today I like, sorry, can you hear me?
you faded out a little bit.
Oh, is it clear now?
Yes.
Now it's okay.
Okay, thanks. Okay, so today I'd like to introduce our new draft, namely Secure DNS Resource Record Update for ACME DNS-based challenges. Okay, so first, a bit of a background story. Our team has been looking into how to deploy ACME to the 5G core network, where we need to kind of issue certificates for the 5G network functions. And we have picked the DNS identifier as the 5G network functions were already assigned domain names. And the ACME protocol was originally designed for domain certificates. And out of all these challenge types, we have picked the DNS-based challenges because they work for both server and client certificates. Yeah, but while we were looking through the ACME RFCs, we realized that there is a small little gap. While these ACME RFCs specify in details how the communication between the ACME client and the ACME server works, they are currently missing the challenge procedure. For example, for the HTTP challenge, how does the ACME client configures the HTTP server to serve the key authorization under the specified path? And for the DNS challenge, how the ACME client updates the domain verification DNS records. And we thought maybe a draft on the deployment guidelines for ACME with DNS challenges could help. Therefore, we came up with this draft. Yeah, so this draft talks about how we can configure the ACME client and the authoritative DNS server to use DNS update messages specified in RFC 2136 and using TSIG or SIG0 for authentication. Yeah, next slide. Yeah, so this is an overview of the architecture. Yeah, so apart from the ACME client and ACME server and the authoritative DNS server, we have introduced this OEM, which represents an entity or a system or a person that performs the configurations for the ACME client and the authoritative name server. Yeah, and the ACME client here will use a key to authenticate DNS update requests sent to the authoritative name server. Yeah, and the rest are just normal RFC 555 stuff. Yeah, next slide, please. Okay, so this page gives an overview of the procedure. So the first step is initial setup, where the OEM configures the target domain name and the TSIG or SIG0 keys used on the ACME client, as well as the authoritative name server. And the key mentioned here is what we call an initial authentication key. And the next step will be to use this initial authentication key to establish a transactional TSIG key used for authenticating DNS update messages. And the third step will be for the ACME client to perform DNS update through the TSIG key configured in the previous step. And the last step will be for the ACME server to perform challenge validation by sending a DNS query to the authoritative name server. And from the graph below, we can see that for both the initial authentication key and the transaction key, we can use either tsig or sig0. Yeah, in our current version of the draft, we have picked tsig for both steps because of the simplicity, but maybe it would be better to use sig0 for the initial key and tsig for the transaction key. Or we might be able to list all the 4 combinations. Yeah, next slide, please. Okay, so this slide lists some other things we need to consider when using ACME with DNS challenges. The first one will be how we should configure the access control of the keys on the authoritative DNS server used for either DNS update or transaction key establishment. And one way will be to restrict the access to specific domains and specific record types. And the second point would be how we can prevent DNS update replay. Yeah, because after a DNS challenge has been completed, maybe the DNS update message can be replayed and the same record will be configured on the DNS authoritative name server. Yeah, I see a question from Henry. Yeah. Sorry, any question?
Guess he got in the queue by mistake.
Yeah, I'll save at the end. I'll ask the question.
Okay, cool. Yeah, so the next one will be how we should perform key rotation or simply using short-lived keys. And also we need to consider whether we want to apply DNS over TCP or DNS over HTTPS to encrypt the DNS update traffic. And the last one would be how we need to clean up the DNS records after use. This includes the domain control validation records and the transaction keys themselves, because sometimes they are also stored as DNS records. Yeah, so that's about it. So we just want to introduce this draft to everybody. So maybe we are expecting some feedbacks here or on the mailing list. Yeah, thanks everyone.
So I suppose the plan is to ask for adoption of this?
We just want to introduce this to everyone first to see if other people find it useful. Yeah, if there are other people who want to see this proceed, then we can make further edits.
Okay, so let's listen to the questions from the queue.
Yeah, so I'm Henry Burghley from Princeton University. Sorry, I didn't mean to interrupt you earlier. But I had a question regarding a ballot that's circulating at the CAN browser forum that might permit long-lived DNS challenges. So instead of this sort of iterative procedure where every challenge you have to update the name server and then do the check, you could simply put a single static token that just sits at your domain, and then the CA just rechecks whenever it has to do validation. So obviously I can't speak to whether that ballot would pass or not, but if that situation became a reality in the future, would we still need this for your use case, or would you simply move to a long-lived challenge and eliminate the need for the ACME client to talk to the name server?
I see. Yeah, I don't think I have heard of the ballot that you mentioned. Can you clarify? Is it going to use the same domain validation DNS record for like multiple issuance of the certificate?
I guess like Yeah, I guess like so I mean, also like I was just hearing from the room that this is, a non-web use case, which I understand, but if that technique was introduced at the CA browser forum for web PKI, I guess I wonder if there's a chance this working group would consider a comparable ACME method if that became the norm. The other question I was curious about is how your technique interoperates with a sometimes used practice of delegating an ACME DNS server via CNAME. So essentially underscore ACME-challenge is CNAMEd out to another server. I guess that helps a little with the permission scoping thing, but then would you imagine like that delegated server running this protocol, or is it primarily for the case where you don't delegate and these records are on the true authoritative server?
Okay, I think if the domain name is delegated to a different authoritative server, then probably this should run on the delegated name server. But maybe if we want to automate the full procedure, then we can perform this on the main authoritative server as well. Yeah,
Sure.
but maybe we need some more details to.
Yeah.
Thank
Thanks.
you.
Hello. I support adoption. I actually came up with almost exactly the same thing in response to the discussion in Settle, because they're trying to do IoT things, and I kind of said, well, why don't we just use ACME and put real certificates on them instead of futzing around? I did get my design beaten up by some of the DNS folk. They convinced me that SIG0 is the way to go. I would just kill T-key completely. SIG0, much more. I don't see any need to rotate the keys. Just pick a public key algorithm that you're confident in the first place. Key rotation is something that we had to do in the 90s because we knew that RSA 1024 was balked. But we had to use it anyway because it was all the machines could do. And finally, if you think about the thing about ACME, it kind of reduced the barrier to entry for doing TLS from buying a certificate to running ACME. The next step is not needing the certificate not being an issue, the domain name not being an issue. And if you look what's happening out there with DNS handles and the AT protocol, there are providers that are coming into being who are going to be managing DNS names in a slightly more sophisticated way than traditionally. And if we could persuade them to do this sort of protocol, that would be a way of getting TLS web PKI certificates out to the endpoint devices in a very powerful way. And I think that that's worth chasing.
And Michael.
Hi, read your document. I'm going to partly respond to Henry, right? It's not a new protocol. This is really, I would say, a operational summary of how to stick together a bunch of protocols that we already have. Some of them are more than 20 years old to do this kind of stuff. The difficulties in making it work, or for most operators, people, is the somewhat arcaneness of some of the documentation and some of the things. So for instance, it turns out that you wouldn't think that naming your tsig key with a trailing dot was important in a bind config file, but it is. Because usually you can omit trailing dots in FQDNs, but in this case it's not. But if you omit the dot, things don't work everywhere. So there's just obtuse things like that. So if the IETF thinks it's useful to publish BCPs on how to use common tools to do this, okay. It might be better as a wiki. It might be better as a a YouTube explainer video, to be honest. But on the other hand, the advice to not use TSIG, but use SIG0, which is operationally more complicated for most people, even though it's more reliable over time, might be something good, you know. So that's like, I'm kind of sitting on the fence here. The other thing I was saying is that the I do this. I CNAME my underscore challenge to another zone. It's a kind of haha zone that I registered 30 years ago. And so I don't really care that much if, you know, I do some operational stupid things and there's some garbage in it. It's called Das Blinkenled, if you remember anyway, whatever. So I think this is sort of good advice, good of things. And in fact, the CNAME, one of the advantages of the CNAME is it lets you move it over into another part where you can make the security maybe more lax or more accessible to more people that operationally, whatever. In other words, you're not going to blow up www.mycompany.com by messing up the DNS update for that if you put it somewhere else. And it's operationally quite smart to do that. So I don't know where to go with this myself, but I'm skeptical about whether this is really necessarily an IETF RFC, unless what we're really trying to say is this is the recommended set of protocols to use. And we really want to make a very strong statement, in which case, yes, that's a DNS 01 update with SIG0 and blah, blah, blah. Okay, let's do that. But no, BCP, okay. So I'll be happy to review it over and over again. And if we decide we should publish it, great. But I equally think, you know, really good documentation that many people have reviewed and that adapts to the changing environment of whatever would also be good. Thanks.
Sorry to Henry Burgley again. Just one other follow-up question that occurred to me. It feels like this serves a very similar protocol role to the ACME DNS REST API service. I was kind of curious if you had any pros and cons. I mean, obviously this is much more standardized and based on standard signed DNS updates, whereas that's kind of a REST HTTP, you know, approach. I was curious if you had pros and cons kind of directly comparing to that service and why this might be a better approach.
I'm sorry, I'm not sure what the REST API you mentioned is. Are you referring to the APIs from the various authoritative DNS providers?
No, this is a special purpose built API. It's a fairly small like software package and GitHub repo, but there's a project called ACME-DNS. They had acme-dns.io, and essentially it's a purpose-built DNS server simply for the purpose of answering ACME challenges. You CNAME to it, and then it runs a REST API endpoint, and they have integrations with CertBot and all the major ACME clients that essentially just, when they do the challenge, they hit that REST API to update the DNS records, and then they do the ACME challenge like that.
Oh, yeah, I think I remember what you are talking about. Yeah, I've seen that repo as well. I think that's like, that repo is one way to like, I think the reason that repo was created is because like currently when people use DNS challenges with ACME, we need to like use platform-specific APIs of various providers, and that's like really not standardized. And normally there are some permission issues, like maybe you can use one key to update all the records under a zone, and that's not really ideal. Yeah, so I'm thinking if we have a document like this that specifies how a authoritative name server could help with ACME DNS challenges, then maybe that will help the implementers of these authoritative name server to like come up with secure solutions out of the box, so we wouldn't need a repo like that anymore.
I think it's a slightly different trust/deployment model that in your model, you're talking about scoped credentials in a sort of strategic manner so that you can only update the ACME challenges. And in this model, they kind of use the C name itself as a way of scoping so that you don't, so it's interesting, but thank you.
Thank you so much.
So my question was going to be about this things to consider slide. It is surprising to me that, sorry, allow me to start over. It was my guess based on reading your document and not going and reading the dependent RFCs that it is saying to glue together, that this proposal was basically a package deal. If you do X, Y, and Z, this will work for you and it will work well, and that's why we recommend it. And seeing things like, oh, we actually might need to prevent replay attacks makes me very concerned that gluing these extant RFCs together doesn't actually provide a package deal best practice that we should be recommending to everyone. And so I totally support publishing something that looks like, here's a set of best practices for how to update a name server to complete ACME DNS-01. I think we should publish a BCP or an informational RFC that talks about that. Like, I have no objection to that. Having to think about what exactly that protocol looks like in order to solve already solved problems like replay attacks and key rotation makes me concerned that these are not the correct building blocks to do that with.
Yeah, actually, we are also a little bit concerned about that because, currently, DNS update is like the only method standardized in the IETF to update DNS records, and that's why we picked this message. Yeah, I think for replay attack, it's already mentioned in the DNS update RFC under the security consideration section, and there is a solution to it, but it's like I don't think it's very polished. So these are the points listed in these slides are like the parts that we have not yet finalized in the draft. So yeah, the draft is still in a very preliminary state. So these are like some things we need to consider if we want to like make it more polished in later versions.
Mike Elmsworth. So following on Aaron's comment, my question is sort of, who is this guidance for? Is this, if it doesn't work in all environments, then would this be guidance for the ACME client operator or the domain owner or the DNS operator? I feel like some of those entities will be, won't care. So who is the target audience of this?
Yeah, I think the target audience will be mainly the client implementers and authoritative servers. Yeah, because currently the most authoritative DNS servers are not really programmed with like considerations of how it will be secure for ACME. Yeah, so I'm thinking, yeah, if we can provide some kind of guideline, then it will help with like making things more secure for ACME.
Okay, since the lines are now clear, I'll say that as in with no hats on, I'm relatively clueless about DNS, and DNS has been an important part of ACME since 85-55. So if the things that we standardize there for to do with DNS are not obvious. It's not obvious how to do them. Then yes, having a document clarifying that is a good thing. Of course, we'll need people with DNS clue, and judging by the discussion here among people who have a lot more DNS clue than I do, it seems that it's not obvious. So that just says that a document is a good idea to have. And of course, we can argue about the content and the specific recommendations even after it's adopted. So in that regard, it tells me that it's a good idea to adopt this document or something similar. Of course, we'll need people with DNS clue, but that's fairly easy to get because there's a lot of them in the IETF, and just tell them, oh, ACME is doing something wonky with DNS, please come and review, and you can get a lot of reviewers. That's fairly so. I think we should talk about this on the list, and I'm feeling positive about an adoption call. But yes, I think this is something that should be taken to the list first, and then perhaps an adoption call. Anyone wants to rush to the mic to object? Okay, so thank you for this presentation.
Thank you.
Next up, we have rats. Who's speaking for rats? Hi.
Hold on. I can pass the control to the clicker. Yes.
That's working. Hi, this is Peter. Last IETF, we presented the ACME rats for the first time, and we made some updates and some other further directions of the designs we're going to do next. So refresh the use cases. We have this one use case that we want to protect the endpoint security and the security of the network that it access to. So in this case, we basically want to only issue certificates to the endpoints that are security inspected. In this case, we might have a WDM that checks the security patch or the security vulnerabilities, and if it passes, it will give a attestation result, and the ACME rats is to use this attestation results or inspection result to redeem a certificate, and that's one of the use cases, the driving use case at the beginning, sorry. And the other motivating use case as proposed by Mike is the use case, in the web case. In this case, a ACME server would be a cloud, host service provider, and also maybe an SDA at the same time. And it will try to make ACME policies to its tenants, for example, domain owner or the cloud the owner, and only to it wants to know certain attributes of the private key or the web host environment that this domain owner is operating on. So it might be like private key, is it on FIPS hardware, or the policy of the is it on KMS? Is the OS or Docker stacks has been recently patched, et cetera, et cetera. So this is another use case proposed by Mike. And it changes from last IETF. Basically, we referenced the drafts from Brandon Weeks' device attest, and we changed the challenge type to device attest. We delete the HTTP challenge type that might not be very useful. We changed how we carry the evidence or attestation results to CMWs. We added the ACME attest claims hint registry because we want to look for specific security attributes. We want to have this kind of template, and this is suggested by Mike. And we added IANA registries, requests for registries. And Mike and Michael provided contents and reviews, so Adam, co-authors. Those who want to collaborate, please do the same, and we will have a monthly call. We'll explain later. So I think that's some progress or some changes, but we think we might to rethink the design. This is also suggested by Michael Richardson about how do we actually put the remote attestation results. So right now, currently, we're putting in a challenge, right? So this might not be the right place. So we have to really rethink about this, because like right now, the Brandon's device attest 01 proves actually a permanent identifier, uses the device attest challenge. And right now, we're actually thinking about more general case, right? Not just one identifier, but a list of security attributes. Does it really goes into the challenge? I think this is something we have to think about, because there are a few good reasons for that, open for discussion. Because number one, challenges are usually for proving ownership of identifiers, not system attributes. And the other one is that the client only required to respond to one challenge. And usually when we want to do this ACME plus RATs, we're actually not trying to use RATs attributes to replace the proof of ownership to identifier. We actually want to complement to it. So we might need a separate system level remote attestation that complements to the identity challenge and not to disrupt the identity challenge So the initial conclusion that we think the challenge might be not the right place to carry it. So right here, also Mike is the lead author of the CSR attestation draft. And right now he kind of suggests maybe we should list the attestation as another item right next to the CSR payload item. And this might be the right place probably to put it in the post finalized object. And also, there are also some kind of requirements that we have to address about, and these are something we have to do in the design after this IETF, is that number one is that how do we request the client to provide evidence or attestation results? And of course, there's something, actually, there's another question that I forgot to put on this page. Because if you're delivering attestation results, that's okay, because it can be standalone verified. But if you're providing evidence, you might have to think about where to find verifiers, right? If the verifiers is provided or appointed by the ACME server, or is there a verifier list? Is there any kind of instructions of how to finding it? That's another question, I think. So that's number one. Number two is that how do we request specific, a set of attributes or claims, for example, like proof of FIPS, proof of OS patches, and that kind of things. So it should be how do we do this specific, customized request, or should we give templates? Right now we give templates. How do we do specific, kind of inquiries? The third one is that I think we need a freshness from the server to the ACME clients that needs to help protect the freshness of this process. Okay, and right now the idea is to add to the post/new order as a different item there, maybe in the authorizations. So the next step will be is that we will start a design team meeting once a month. Maybe the time, we can discuss the time, but right now we have the Tuesday or Thursday North American morning time. And if you would like to contribute or collaborate, please join the call and provide some contents or some reviews and email us. And also, as Hank insisted, Hank has reviewed the slides, and I added this claim to the slides. Yes. Questions, comments?
Aaron?
Yeah, so I I mean, maybe this is a discussion that is better in the monthly call that you're going to start up, because I think clearly we could rabbit hole on this forever. But it seems to me like what you want is a new identifier type that is a sort of generic, like attestation claim, like the identifier is
No,
attestation,
we
and
don't
the
want that.
value of the identifier is the JSON blob of all of the claims that the server wants. And then the challenge is the attestation over all of those claims. Like, that's not a singular identifier. The identifier mechanism is a way for the ACME server to request an attestation over a specific set of parameters is included in the identifier value. Like, I would love to hear why this doesn't work, because it sure sounds like it works to me.
No, we do not, because we don't want, it's unrelated to anything that goes in the certificate. We're not looking for, we're not trying to prove ownership of foo.example.
That seems fine. Nothing in the ACME RFC says that every single identifier included in the order object has to end up in the certificate SAMs.
They're not identifiers, and we need to do we don't think the state machine actually includes the ability to do multiple challenges. It's a choice of challenge, not do all of these, but do one of these. And it's up to the client right now to decide which one, as far as I know.
I don't follow why that's a problem. But
because if I prove I am trustworthy, that doesn't give me ownership of DNS.Google, does it?
No, but the order will have 4 identifiers associated with it. One of them is example.com. One of them is here's an attestation that you need to do. And the client has to validate some challenge associated with both of those identifiers. So it goes and it does B2B for example.com, and it also produces an attestation and posts that attestation to the challenge endpoint for the I need an attestation identifier.
So I think what you're saying is that we should do this process as within the order processing, not within the challenge processing. And I think that we're in agreement that doing it as a challenge within a single identifier is wrong, but you're suggesting we go to the order object. My suggestion was that it should have been in the account object, but I've had pushback on that. Okay, so maybe we are in agreement, and just I'm not listening to you very well.
Yeah, I mean, this is the sort of thing where, as I said, I think we could rabbit hole on it for a long time, and I don't need to do that in the midst of this meeting. But I think that the ACME identifier mechanism is very, very flexible. And if you construct an identifier that looks like the right kind of thing, you can then include that identifier alongside whatever other identifiers you want in the order object, and then fulfilling that identifier with whatever challenge is associated with it can prove just about anything you want.
Okay, so for future viewers on YouTube, the person responding to Aaron was Michael Richardson. Yeah, okay.
Mike Ounsworth. So Aaron just said the word identifiers about 35 times, and that makes me uncomfortable because attestations are not identifiers. If what I'm proving is like that my hardware is running a genuine Windows copy or something, that's like not an identifier. And so calling it identifier gets you into weird semantics. I'm not saying maybe that's the wrong place in the protocol, but the semantics there get super weird. Also, we've got this mechanism in LAMPS where you can put an attestation inside a CSR, which means that the way to prompt for it should expect the response to come back in a CSR, not in a challenge response, if we want to reuse the stuff in LAMPS.
Yeah, really quickly, I agree that identifier is not the right word for this thing, but identifier is the thing that is the name that the ACME protocol uses for a challenge that we want you to fulfill. Like the ACME protocol uses the word challenge for way to prove something to the ACME server, and it uses the word identifier for thing the ACME server wants you to prove control of. And like those words have a lot of semantics attached to them, but the protocol itself really doesn't. And I think it is flexible enough to prove control or ownership of a lot of things.
Fair. Okay, fair. Words are words. A point that MCR brought up, and maybe we should just punt this to the design team calls. But a point that Michael Richardson brought up is, can this in ACME the way it's specified now, can the server say, here's 4 challenges, I need you to fulfill one of these 3 and mandatorily that 4th one?
No, the ACME server would do that by creating 2 separate identifiers and putting 3 challenges on one of them and 1 challenge on the other.
Okay. All right. That's a design space we hadn't stumbled into. Cool. Awesome.
That of you all? Thanks.
Thank you. So, jot claim constraints. Chris.
Hi, I'm Chris Wendt. I normally hang out in the STIR working group, and this is sort of the context of this presentation. So basically what we're proposing here is an additional authority token profile. Authority token is a concept that we have represented in RFC 9447 as a general framework for STIR-related certificates and the use of ACME to validate and define a challenge that can be used to validate that. We've defined already TN auth list. TN auth list is an extension defined in 8226. I'm happy to report, and we have a RFC 9448 that defines that. I'm happy to report that's in very wide usage for STIR-Shake in general in the US, Canada, I believe France and Brazil at this point. So that's great. We have a few new use cases, mostly related to the delegate certificates that are used at the TN level, and also use an extension defined in 8226 called JWT claim constraints. So we thought the natural thing is to create a new authority token profile that corresponds to those JWT claim constraints. Basically, the way it's used is if you delegate a certificate to somebody that's not authoritative over information or maybe perhaps not trusted, the claim constraints are used to limit their ability to use those certificates for different claims they might make in a passport JWT. I'm happy to go in more depth if anyone in the audience wants to know about that, but I'll sort of go through that quickly and sort of stop there. The current draft reuses all the mechanisms of authority token that we've defined. The current state of the draft is fairly copy and paste-ish from the TN auth list, although it does have some of the specifics. My plan, if if it's something that we can work on in this working group, would be to provide more detail on the use of JWT claim constraints, some of the mechanisms that may produce how the JWT claim constraints are constructed, and how the challenge, more details on how the challenge would be validated, and some things like that. Oh, and I also did present this at the STIR working group earlier this week and got fairly good consensus that this is a good idea from the perspective of the STIR working group as well. I think this can be fairly quick, but certainly looking for feedback from the group, and some feedback on whether it's something we can work on. I know it's not generally a topic talked about in this working group, but
well, we can still talk about it on the list.
Sounds good. Thank you for letting me present it.
Right. So that gets us to our last presentation about public key challenges.
Hello, everyone. We are here to present a draft that ACME extension for public key challenges. Next slide, please. First of all, let's have a general explanation and introduction of this content. Our proposed PK01 challenge focus on verifying the user's controller of the private key corresponding to the specified public key in the certificate. We have proposed a security model for risk of public key identify inconsistency in the three phases of ACME. That is, the public key replacement attack when submitting CSR. Our proposed PK01 challenge addresses this risk well. In the follow-up, we also proposed a simplified optional process for removing CSR. For scenarios where a device applies for a certificate for itself, this can be addressed with a whitelist measure. Lastly, a best practice combined opaque is presented for the purpose of issuing temporary certificates for user logging into public device. Next slide. Then we come to the background of our presentation of PK01. Where there is a risk of identity in the ACME, and we present the PK01 challenge under that risk to reduce it. The standard ACME can divide into three phases: account management phase, challenge phase, and security certificate issuing phase. We found that after the first phase, all messages are protected by the public key situation of the account, but there is a problem of the dissociation in phases 2 and 3. That means ACME survey verifies and caches the identifiers that pass the challenge in phase 2, but not bonding the public key in CSR. So in the phases 3, the ACME client can replace the CSR with a CSR of another public key. And the ACME server does not check the public key identity. Here's where the problem comes in. The ACME server can still issue certificates for CSR with replaced public key, but the actual challenger and the final certificate owner are not the same. From this, our motivation for proposing PK01 is to verify that the client wants a given key to appear in the certificate, or that it controls the corresponding private key. Next slide, please. For the above proposed risk, there exists other work with similar think. We can roughly divide the existing challenges into two main groups: insurance certificates for resources and insurance certificates for user or device. What can be seen is that there are similar attack scenarios in both types. In the proving ownership of resource, adversary can obtain ACME account credentials to impersonate the victim's survey in the phase 3, thus obtain false certificate for that resource, as pointed out in ACME++. Our work focuses on proving ownership of a device identity. As an example, ACME client is deployed on the EMS, that is the element management system, to request the certificates on behalf of device A, B, and C. Then in these scenarios, EMS will act as an adversary to replace the CSR, thus obtain a fake certificate and further fix the device. I hope I have made myself clear. Next slide, please. On this page, we further compare these two types of attack models. The attack path on the left occurs after complete the phase 2 challenge, where the phase 3 ACME client credentials are stolen, thus the adversary gets a fake certificate. Similarly, we had the same attack path, where in the phase 3, EMS replace the CSR to issue a certificate and eventually obtain a fake certificate. In other words, there is a mismatch between those who take on the challenge and those who finally receive the certificate. Next slide. On this page, let's go into more detail about our security model. We set up an enterprise scenario where there is always a need to issue certificates for multiple devices, so there is usually an EMS that operates for a large number of devices. However, EMS can replace the CSR of C with the CSR of D in phase 3 to apply for and eventually receive a certificate. Thus, the device D has obtained a certificate and the device D is able to fix the device C. This is reasonably common in enterprise situations and is highly risky. Next slide. We present the PK01 challenge to define the against public key replacement attack. Simply speaking, in the order submission phase, assign PK as the identifier, thus even though ACME client replaces the public key in the CSR, it fails to pass the ACME survey validation phase. Next slide. Now coming up are our PK01 challenge. First, we present the two new types of identifier type. PK is used to apply for certificates for a specific public key. CSR or a self-signed cert can be used in case where specific identifier information need to be bound. Next slide. Our proposed PK01 challenge proposed unfolds in two main perspectives. One follows the standard ACME process, and the second take into account the simplification of the CSR process. We will start with the first standard process. When ACME client selects the PK0 challenge, the authentication process is initiated, redirected to the challenge device and the IDP via URL. IDP and the device completes the authentication. Then the IDP returns the result to the ACME server, which updates the challenge results. At the time of CSR submission, ACME server will perform a public key consistency check to avoid PK replacement, and the final certificate will be issued after the verification passes. Next slide. Let's take a look at the simplified process for removing CSR. Considering that the CSR contains a lot of unnecessary information and passing the file is cumbersome, and the process of removing the CSR is proposed. That is, the certificate can be issued directly after the ACME server validation is completed. The step can be selected as an optional choice in the PK01 challenge message. Next slide. The authentication between the device and the IDP in the PK01 process can use a different authentication protocol. For example, the more common public key signature verification, opaque or NIZK, and so on, which can be selected and expanded according to different scenarios or needs. Next slide. Finally, we like to maintain that the original intent of this draft was to use ACME as opaque to enable the issuance of temporary certificates with one-time key, not only for the device but also for people. As shown in the figure, step 2 completes the opaque PK01 challenge. Well, we are now placed in a scenario where a user does not have their private device with them and need to log into a public device to join a meeting. What we need to do is to issuing a temporary certificate to the user. Well, ACME at opaque is the best practice. Next slide. For our follow-up work, we will further discuss and refine the content of our drafts to always point of discussing the pros and cons of the challenge types such as TLS, LPN01, PK TLS01, and others. It's all about the need to verify that the client wants a specific key to appear in its certificate, and the client controls the corresponding private key. The final goal is the same. We will follow up with a complete in-depth analysis to try to refine the idea. And thanks for the comments and the discussion. That's all. Thanks.
So, Aaron.
So I have just one big question about this, which is, if the ACME client is compromised or malicious and can substitute the CSR that the real client, the device or the user, wants to present in the finalized request, what prevents that malicious ACME client from also substituting the public key that the real client wants to present in the new order request. If we're going to use a public key identifier type, then that identifier has to be presented in the new order request. Otherwise, the server has no idea what pub key the client should prove control of. And the malicious client could just put its own public key in that request, prove control over that public key, and get a certificate with the substituted pub key. I don't, so like my comment is, I don't think it's possible to protect against that. And my question is, am I wrong?
In my opinion, I think you said we assign the PK as the identifier in the certificate. Then we take the challenge by the device itself. So when complete the challenge, it sends the CSR to the client, but the client maybe trans the CSR. Then send the replace the CSR to the ACME survey, but the ACME survey this time ACME survey will check the PK is the consistency. If it finds it done the same in the challenge phase, it will don't pass the challenge and don't ensure the certificate. So,
right. I understand that the server will be checking for consistency between the public key in the CSR and the public key in the challenge. But a malicious ACME client can also replace the public key in the challenge, and then they will match. So the server will not have any way to know that a substitution has happened.
You mean in the phase 2, the client replace the PK?
Yes, at the very beginning of the process, when the client first says, I would like a certificate for this device or for this domain name, and it also says, and I would like this public key to be in that certificate, the malicious client can just lie about the public key at that time as well.
Okay, I got your I think we can use some whitelist measures to resist this. For example, we put some PK in the IDP. So when we take the challenge for the PK is not fair. So we didn't pass the PK.
What stops the malicious client from saying, my identity provider is this other malicious identity provider over here, and you will find the public key there because I've coordinated with, like, if the ACME client is compromised, fundamentally, from the perspective of the ACME server, the ACME client is the only entity in the world that exists. The reason that all of the request messages in RFC 8555 have an anti-replay nonce in them, and the reason every single request message is signed, is so that if you have to have a proxy, if you have some back-end service that can't talk directly to the ACME server, it can still do everything, sign all its requests, manage its own ACME account, and the proxy can't interfere with that. But if the proxy is the thing signing all of the ACME requests because the client in the backend is speaking some other protocol to that proxy, and that proxy is malicious. The ACME server has no way to know that there is someone else behind there that it should trust and that it shouldn't trust the client. The client is the only trustworthy entity in the world as far as the server is concerned.
Can I respond to Aaron's comments? Thank you. I think your comments make sense, and but we want to emphasize our use case is special, and for the enterprise campus, you can understand that in our case, the ACME client worked as like a proxy. It's not the final device who requests for the certificate. So yes, yes, in general, we should anyway we should trust the ACME client. But if we focus on this special use case, maybe we should not totally trust the ACME client. We should be more strict on this case because the ACME client can really do some bad thing, you know, to replace the public key in the CSR CSR request phase. So I guess maybe in our draft we should emphasize this kind of attack model, and maybe ACME protocol need some extension, you know, to, for example, for the ACME server, if under this consideration, there are some policy or some more check should be performed, you know, to make us, you know, we cannot trust the ACME client in all of the time, at least for this special case. I think we still have way to deal with special case. I'm not sure whether, you know, my comments has answered some of your concerns.
Mike Ounsworth. So I think there's, sorry. Yeah, but Aaron, I think, yeah, let me go first. So I think there's two points here. I think one is the ACME client is very powerful. It needs administrative access to the DNS. It needs administrative access to push to the HTTP server. I think this work is clever. Like, I think this work is a neat application of cryptography, and I'll give you points for it being interesting. But I think if this working group starts to consider the client to be malicious, I think we have much larger problems than public key replacement. I think we have DNS poisoning. I think we have server content takeover. So that's point number one. And then point number two is, I think what Aaron is trying to say, if I can attempt to paraphrase, is if we're going to not trust the client, then we need to not trust the client. This, I think, is proposing to partially trust the client. Like, we trust their first message, but then we don't trust their second message. And that's a weird sort of in between. I'll sit down now. Henry?
Okay.
I
like
you have a
to.
question, right? You have a question?
Yeah, just a brief one. I was just kind of curious because I have to admit I come much more from the web PKI, you know, standardization process, and there generally PKI use cases get partitioned into what you might want to use web PKI for and what you want to use internal PKI for. And I know ACME really reaches beyond that web PKI only use case and is proposed for a whole lot of PKI context. But going back to the point before, it's kind of interesting because in web PKI, there's a very explicit trust model that the client has to be trusted for the very reason stated earlier. It has a ton of power. It's often co-located with the server. And it seems that it's kind of like the trust models are sort of diverging. So I'm kind of curious if like ACME as a whole is intended for those use cases while still supporting web PKI use.
Sorry, just a clarification to this gentleman's question. This is not, no, not your case, not YPKI. It's for the enterprise. So, and there's a proxy, like worked at the ACME client to request the final certificate for the device. Our case is very specific.
So I was just wondering, like, in light of it being very specific, is there a reason why the ACME protocol, which also has to support these web PKI uses, is the best protocol as opposed to something custom built for that specific use case?
Because if we use ACME in this kind of use cases, there's some, some threat, some attack. So we need to enhance the current protocol to protect against this kind of attack. So that's motivation of that we propose this kind of use case and the potential solution for it.
Okay.
Okay, thank you. I guess we need more clarity of the use case of the background for this attack in the mailing list. So be happy to discuss it there. And so thank you for the presentation. And this brings us to the any other business. And Mike wanted to say something, so come up.
Thank you. I'll try and be quick. So I have a pair of drafts for auto discovery, server auto discovery and client auto discovery that I believe are expired. I believe we never did an adoption call for. They got sent back to design team several times. Just a refresher. So the problem statement there is CAB Forum is pushing for shorter certificates, 45-day and maybe below. And we did a survey of like small cloud providers, like, the kind of cloud provider where you bring your pile of HTML pages and they'll throw it up somewhere for you, right? Small personal use stuff. And there, to get a certificate for that domain, typically you either use the CA that your cloud provider has a business relationship with, which is almost always Let's Encrypt, or you upload a PEM file. And across the providers, it's basically automate, and they sometimes don't even tell you which CA they're using, or it's upload PEM file. Upload PEM file is not going to work nicely. Like, that's going to die with 45-day certs or less. And cloud provider gets to choose the CA, leads to lack of diversity, single point of failure problems. So we think that either way, there's a problem here that needs a technical solution. We need a better way for the domain owner, the person who owns the domain, who owns the DNS, to be able to tell their cloud provider, here's my CA, here's the CA I want you to use, here's my ACME account or my CA account. Please, if it's a paid CA, please build a certificate there. I want to be able to control which clients can issue to my domain. I want to be able to revoke certificates issued to my domain. I want control of the certificates, not my cloud provider. So we think there's a real problem here. We proposed a pair of technical proposals, the client discovery and server discovery. Now comes the political part. My employer no longer cares. So I am no longer going to work on these drafts. They are there. If someone else wants to take them, I would be more than happy to be third author, fourth author. I'd be happy to be document shepherd to get these through, because I think that for the public good, this is a problem that should be solved, but I will no longer work on them. Thank you.
Hi, Henry Burgley here from Princeton University. I guess I don't have a great answer for who will work on them, but I will say that this technique expands beyond just small providers. If you go to Amazon Web Services and use kind of like their load balancing service, you can either hand the keys of the kingdom to Amazon Trust Services, which sort of integrates full stack with Amazon Web Services, or you can upload your PEM file. So unless you have a very advanced DNS automation system, you're kind of stuck using Amazon Trust Services, and you might want to use someone else. So just saying, this extends kind of across the provider spectrum.
Yeah, this is sounding to me like this is a new working group, and possibly the same as the IoT working group, and looking at how you do the generic thing of how you provision something running in the cloud with all the things that you would want. And if you want to do it well, you might want to look at threshold.
Anyway, so if anyone is interested, Mike Ounsworth, if anyone's interested in taking over leading these drafts, I'm happy to hand over leadership of them.
Okay, do we have any other business? Okay, then. Thank you all and see you in Madrid.
Thanks, everyone.
Thanks. Thank you.
Okay, so I'm sitting here looking.
Bye, you all.